Hi there, I'm Sridhar Chandrasekaran, and I'm excited to present a study series on power transmission line construction. Drawing from my extensive career experience, this series is designed to provide practical and theoretical insights that can be directly applied to real-world projects. The primary goal of this study is to help engineers and managers deepen their understanding of transmission line construction, enhance the quality and efficiency of their work, take accountability and ownership of the tasks they manage. We began this journey by exploring the basics of electricity, how it's generated, its requirements, and its sources. From there, we've covered critical stages such as tendering, bidding, and project initiation. Moving forward, we'll delve into implementation, execution, and finally, project handover. Given the complexity of this topic, the content is divided into chapters released weekly. Along the way, we'll also integrate discussions on essential complementary areas, including engineering ethics, legal considerations, health and safety compliance, human resource management. These vital aspects will be seamlessly woven into our technical discussions to provide a holistic perspective. Each week, I'll release a new video featuring key technical topics, ethical dilemmas, and considerations, a thought-provoking quote to inspire meaningful reflection. Currently, we're in Chapter 10, delving into understand about project documentation. There's still so much more to discover, so stay tuned for the upcoming chapters. Thank you for joining me on this journey of learning and growth. Disclaimer. Just a quick note. The content in these videos is meant for informational and basic educational purposes only. These videos aren't intended to provide professional advice or endorsements. This helps set the right expectations about the nature of what we're sharing, especially since we draw on material from various sources under the principle of fair use. Documents submission and approval. In this chapter, we will explore the different types of documentation required for running a transmission line project and understand why these documents are essential. Project documentation is a critical component of transmission line construction. It encompasses all stages of the project, from design to site execution and supply, providing the structure and support needed to ensure the project is completed efficiently, safely, and in compliance with regulatory requirements. In the upcoming sections, we will delve into the specifics of approvals and processes for these documents. The role of project documentation. It serves as a guideline for executing and monitoring the work. It can be categorized into three primary functions. 1. Procedures and methods. Detailed instructions on how specific tasks should be performed. 2. Compliance and approvals. Ensures all work meets regulatory standards and receives certification upon completion. 3. Progress and verification. Provides evidence of work completed, enabling review, approvals, or future reference. These documents are vital for ensuring the smooth progress of the project while meeting technical, safety, and regulatory standards. We will learn about all these aspects in detail, so stay tuned. Introduction to project documentation. We will delve into the types of documents required at various stages of a transmission line project, focusing on design, supply, construction, and completion. Each category of documentation plays a critical role in ensuring the smooth execution and successful delivery of the project. These documents are essential for maintaining compliance with technical standards, regulatory requirements, and client expectations. Let us understand each category in detail. 1. Design-related. Drawings, calculations, tower profiles, and plans. 2. Supply-related. Vendor approval, certificate of compliance, type test report, material specifications, material test certificates. 3. Construction-related. Inspection reports, foundation test results, and installation certificates, QA and QC HSE. 4. Completion reports, final inspection certificates, energization reports, and handover documents. Before getting in to understand the documentation process, let us know how these documents are handled. How documents are handled. In transmission line projects, document management plays a crucial role in ensuring the smooth execution of the project across various phases, from design to construction and completion. Proper handling of documents ensures that the right information reaches the right stakeholders, avoids errors, ensures compliance, and improves overall project efficiency. Let us understand the three main steps: how documents are initiated and handled in a transmission line project. 1. Document lifecycle in transmission line projects. 2. Software used to handle documents in transmission line projects. We will try to undrape these topics in detail. First, understand what is document lifecycle in transmission line projects. Documents in a transmission line project are handled through a structured lifecycle. Creation. Documents are created by respective teams. Design team prepares design-related documents like drawings, calculations, and profiles. Engineering team develops reports such as soil investigation, material testing, and site inspections. Commercial team creates billing reports, procurement records, and financial control documents. 2. Review and approval. Documents are submitted for review to the consultant engineer, CE, or the client. Documents undergo multiple revisions based on feedback until approval is granted. Approved documents are stamped, signed, and shared for implementation. 3. Storage and distribution. Documents are stored digitally on document management systems, DMS, or shared drives. Approved versions are distributed to stakeholders, contractors, project managers, engineers, to ensure everyone has access to updated information. 4. Updates and revisions. During construction or execution, changes may arise that require document updates. Revisions are carefully tracked using version control systems to avoid confusion. 5. Archival. After the project is completed, all documents are archived for future reference, audits, and maintenance purposes. This includes as-built drawings, test reports, certificates, and final approvals. Second, software used to handle documents in transmission line projects. To ensure efficient handling of documents, various document management software, DMS, and tools are used. These platforms help with storage, tracking, sharing, version control, and approvals. EDMS, Electronic Document Management System, is a centralized software solution designed to manage and store documents electronically throughout a project's lifecycle. It helps organizations create, track, store, retrieve, and manage documents efficiently while ensuring security and compliance. Key features of EDMS: centralized document storage, stores all project-related documents, drawings, contracts, reports, RFIs, etc., in a centralized repository. Enables easy access and retrieval of files for all project stakeholders. Version control tracks changes to documents, maintaining version history to ensure users work on the most updated version. Prevents errors caused by outdated or duplicate documents. Access control and security allows administrators to set user permissions, view, edit, share to maintain document confidentiality. Enhances document security with encryption and audit trails. Collaboration tools facilitates real-time collaboration between teams by enabling document sharing, review, and approvals. Ensures transparency by tracking changes, comments, and document status. Workflow automation automates document workflows, such as approvals, notifications, and routing to the right stakeholders, reduces manual intervention, and speeds up review processes. Search and retrieval provides powerful search tools with metadata tagging to locate documents quickly. Filters documents based on keywords, date, or version. Integration with other tools. Integrates with project management and design software like AutoCAD, Revit, and Microsoft tools for seamless workflows. Software used for construction projects. Managing plans, RFIs, submittals, and approval workflows. Engineering teams, centralizing technical drawings, specifications, and reports. Compliance and auditing, storing documents for regulatory reviews and maintaining audit trails. Benefits of EDMS are improves document organization and accessibility, reduces errors and delays by maintaining version control, enhances project efficiency through workflow automation, ensures compliance with industry standards and legal requirements. Let us explore some of the widely used project management software tools that enable efficient project planning and execution. These include Procore, PlanGrid, Primavera, and Microsoft Project. Let us delve into each of these software tools in detail. Starting with Procore. Procore is a cloud-based construction project management software designed specifically for large-scale construction projects, including transmission line construction. The key features are document management. It centralizes all project documents, drawings, specifications, RFIs, submittals in one platform. Project scheduling to enables timeline management with clear visibility of project milestones and critical tasks. Collaborative tools to allows teams to collaborate in real time, ensuring updated information across all stakeholders. Budget and cost management tracks project costs, budgets, and forecasts to ensure financial control. Quality and safety management provides tools to document inspections, quality checks, and safety compliance. Mobile access. Procore can be used on-site through its mobile app for instant updates, document uploads, and issue reporting. This software is suitable for managing large and complex projects in construction, infrastructure, and engineering. Ideal for contractors, owners, and construction managers who require transparency and real-time data sharing. And the benefits are improved collaboration and communication across all stakeholders, reduces errors and delays by providing real-time access to documents and schedules, enhances project visibility with dashboards and reporting tools. Secondly, let us understand second software. PlanGrid is a construction productivity software that focuses on handling blueprints, field reports, and document collaboration. It is part of the Autodesk Construction Cloud suite. The key features are drawing management, allows users to view, mark up, and share updated drawings and blueprints on mobile devices. Field reporting simplifies daily reporting, punch lists, inspections, and progress documentation. Document version control ensures only the latest versions of drawings and documents are accessible to the team. RFIs and submittals streamlines workflows for submitting requests for information, RFIs, and other approvals. Mobile integration designed for mobile use, allowing teams to access plans, issues, and tasks in the field. Offline access provides offline functionality, enabling teams to work in remote areas with limited connectivity. This software is suitable for field teams, subcontractors, and engineers working on site, widely used for managing blueprints, site inspections, and punch list workflows. The benefits are reduces delays by providing quick access to updated drawings and field documents, enhances productivity through real-time collaboration and issue resolution, improves accuracy in reporting with detailed markups, photos, and annotations. Next, let us understand. Primavera, Oracle Primavera P6. Primavera P6 is a highly advanced project scheduling and management software widely used for large-scale complex projects, including transmission lines, construction, and infrastructure. The key features are project scheduling allows for detailed scheduling using Gantt charts, critical path method, CPM, and resource allocation. Resource management enables allocation, tracking, and optimization of labor, materials, and equipment. Risk management helps identify, analyze, and mitigate project risks to ensure timely completion. Cost control tracks budgets, actual costs, and variances, ensuring financial control. Multiple project management supports managing multiple projects simultaneously with robust reporting tools. Reporting and analytics provides detailed dashboards, customizable reports, and performance tracking. This software is ideal for industries like construction, power transmission, oil and gas, and aerospace that require advanced scheduling and resource optimization used by project planners, managers, and engineers handling high-budget, multi-stakeholder projects. The benefits are ensures precise project scheduling and resource management for on-time delivery, helps manage project complexities with risk analysis and cost control, enhances decision-making through accurate progress tracking and reporting. Finally, coming to Microsoft Project. Let us understand that these are not the only document control software available. The software mentioned here are some of the commonly used tools for managing documentation in transmission line projects. However, There are many other specialized software solutions designed for various types of construction, design, and project management needs. The ones presented have been selected to provide a general understanding of document control in the context of transmission line projects. Microsoft Project is a flexible project management software used for planning, scheduling, and tracking projects across industries. The key features are task scheduling, helps create project plans, define tasks, set dependencies, and manage critical paths. Gantt charts provides a visual representation of project schedules and task progress. Resource management allocates resources, tracks workloads, and optimizes usage. Cost management tracks budgets, forecasts costs, and compares actual expenditures. Reporting generates visual reports and dashboards for project progress, resource utilization, and financial status. Integration integrates seamlessly with other Microsoft tools like Excel, Teams, and SharePoint. This software is suitable for medium to large projects across industries like construction, IT, engineering, and business operations, used by project managers to plan and monitor progress efficiently. The benefits are: simplifies project scheduling and resource management with user-friendly tools, provides clear visibility into project progress and budgets through detailed Gantt charts and reports, enhances collaboration by integrating with Microsoft Office tools for seamless workflows. As we have discussed the handling of documents, let us now delve into our first topic, design-related documents. Explore the process of the purpose, preparation, submission, and approval of documents. As we have started the design documentations, let us understand the purpose of it. The purpose. Design documents act as the technical foundation upon which all aspects of the project are built. These documents serve multiple purposes, ensuring that the project is executed efficiently, safely, and in compliance with contractual and regulatory requirements. Design documents provide detailed specifications and drawings that define the physical structure of the transmission line. This includes the design of towers, foundations, and other components. Specifies the height, type, and layout of towers based on the terrain and line routing. Ensures the towers are securely anchored, even in challenging soil conditions. Outlines the type, size, and material of the conductors to ensure they can handle the required voltage and current capacity. The documents outline how the transmission line will perform under various operating conditions. This includes ensuring the line can transmit electricity efficiently without disruptions or failures. Ensure the line can handle expected electrical loads. Prevent excessive sagging or tension that could compromise line performance or safety. Ensure the line is insulated to prevent short circuits or electrical hazards. Safety is paramount in transmission line projects. Design documents include calculations and specifications to ensure the line is safe for workers, the public, and the environment. Specify safe distances between conductors and the ground, buildings, or trees to prevent accidents. Ensures proper grounding to protect against electrical faults and lightning strikes. Verifies that towers and foundations can withstand wind loads, seismic activity, and other environmental stresses. In continuation to the design documents, let us continue the topic, the purpose of design-related documents. Design documents provide a clear roadmap for contractors, engineers, and construction teams. They serve as the reference point for executing the project. Provide step-by-step guidance for assembling and erecting towers, laying conductors, and building foundations. Ensure that only approved materials are used during construction. Offer detailed instructions on how to carry out specific tasks safely and efficiently. Design documents help ensure the project adheres to industry standards, environmental regulations, and contractual requirements. Ensure compliance with international standards like IEC, ISO, or local codes. Account for measures to minimize environmental impact, such as routing around sensitive areas or reforestation plans. Provide all necessary calculations and specifications required for client and government approvals. Design documents are not only used during construction, but also serve as references for monitoring, testing, and maintaining the transmission line. Reflect changes made during construction for accurate maintenance planning. ensure the line performs as expected before commissioning, help identify potential issues during routine maintenance. The purpose of design documents is multifaceted. They define the transmission line's structure, functionality, and safety standards while guiding the construction and ensuring compliance with regulations. By serving as a technical foundation, these documents are indispensable for the successful execution, monitoring, and maintenance of the project. In continuation to the design documents, preparation of design-related documents is a meticulous process carried out by the design team, ensuring they align with multiple critical factors. The design team prepares documents based on the specific requirements outlined in the project contract or by the client. These specifications cover technical details such as material properties, load capacities, conductor types, and tower designs. The design ensures that all project components meet industry and regional standards, guaranteeing compatibility and performance. The team adheres to recognized standards such as ISO, IEC, or local country-specific regulations. For example, BIS in India, ANSI in the US. Specifications for voltage levels, clearances, and insulation requirements are included to ensure reliable operation. Tower load calculations follow specific guidelines to withstand wind, seismic activity, and environmental stresses. The design team tailors documents to the topography and geology of the project area. For example, mountainous regions may require special tower designs with higher foundations. In areas with weak soil, foundation designs are adjusted to include deep piling or other stabilization methods. The documents detail how the transmission line will traverse challenging terrains, avoiding obstacles like rivers or densely populated areas. The documents ensure compliance with occupational safety norms, protecting workers during the construction and maintenance phases. Safety provisions include minimum clearance levels to prevent hazards from high-voltage lines, detailed earthing designs to safeguard against electrical faults or lightning strikes. The design documents integrate environmental impact mitigation measures to minimize harm to ecosystems and communities. Considerations include use of low-impact materials to reduce environmental degradation, routing transmission lines to avoid sensitive areas like wildlife habitats or cultural heritage sites, plans for reforestation or compensatory measures where necessary. So the preparation of these documents is a collaborative effort by the design team to ensure every aspect of the project meets technical, safety, terrain, and environmental requirements. These detailed and thoroughly reviewed documents form the backbone of the project, enabling smooth execution and compliance with all applicable standards. After understanding the purpose and preparation of design-related documents, the next step is to understand how these documents are submitted for review and approval. The submission process is crucial as it ensures that the project's design complies with technical specifications, safety standards, and contractual requirements. Here's a detailed explanation of the process. In continuation to the design documents. Design document submission. Once the design documents are finalized, they are compiled along with all the necessary supporting details. These include technical calculations, drawings, material specifications, and any additional data that support the design. The documents are submitted via the approved electronic portal, following the agreed-upon format and nomenclature specified in the contract. Each document is named and categorized systematically for easy identification and reference. Many projects utilize advanced document management systems or cloud-based platforms to facilitate seamless submissions and tracking. The consultant engineer CE reviews the submitted documents to ensure they align with the client's specifications and industry standards. During the review process, the consultant engineer communicates directly with the contractor's design team to fulling. Seek clarifications on specific design aspects. Request corrections or modifications if needed. Ensure that the design adheres to technical and safety standards. The contractor's design team works closely with the consultant engineer to address all concerns and make necessary revisions until the CE is satisfied with the design. Once the consultant engineer is convinced of the design's compliance and feasibility, they present the approved documents to the client for their final review and approval. The client reviews the consultant engineer's recommendations and approves the design. This step officially validates the design, allowing the contractor to proceed with execution as per the approved plans. If the client raises additional concerns, the documents may be sent back for further clarification or revision. The key points to ensure smooth submission and approval are by ensuring all documents are error-free and adhere to the specified format. Submissions should meet project deadlines to avoid delays, and by establishing clear lines of communication between the contractor, consultant engineer, and client to resolve any issues quickly, and strictly following agreed technical specifications, standards, and nomenclature. In continuation to the design documents. Approval process of documents. The approval process for design-related documents in transmission line construction is structured to ensure that the project meets technical, safety, and regulatory standards. Both consultant engineers, CE, and the client play critical roles in this process. Once the contractor's design team prepares detailed documents and submits to the consultant engineer and the client through an approved electronic portal, the consultant engineer, CE, reviews the submitted documents to ensure they align with the client's specifications. Regulatory and technical standards. Industry best practices for safety and performance. For example, the CE checks the tower and foundation designs for structural integrity, sag and tension calculations for conductor alignment, and the safety standards, such as clearance requirements and grounding systems. Once they check the required standards as per the proposed design requirement, if discrepancies or unclear elements are found, the CE provides comments and requests clarifications or corrections. The contractor's design team addresses the concerns and resubmits the updated documents. The CE may organize meetings or discussions with the contractor's design team to clarify complex elements or resolve specific issues. The design team incorporates feedback from the CE, refining the documents until they meet the required standards. Once the CE is satisfied with the design, they approve the documents. This approval signifies that the design complies with all technical, safety, and regulatory requirements. The CE explains the approved design to the client, highlighting key aspects and justifying the design's compliance and feasibility. In continuation to the design documents, the client reviews the CE's recommendations and the design documents to ensure alignment with their project requirements. If the client is satisfied, they provide formal approval, enabling the contractor to proceed with construction based on the approved design. If additional concerns are raised, the documents may be sent back for further clarification or revision. The key considerations for a successful approval process are by establishing open channels of communication between the contractor, CE, and client, ensures that feedback is understood and addressed promptly. Documents must strictly adhere to agreed specifications, industry standards, and regulatory requirements to avoid delays. Using an organized electronic portal and clear naming conventions helps streamline the review and approval process. Well-prepared documents with all supporting details reduce the likelihood of repeated revisions. The approval of design-related documents is a multi-step process involving meticulous review and collaboration between the contractor, consultant engineer, and client. While the CE focuses on technical compliance and safety, the client ensures the design aligns with their project objectives. The iterative nature of this process ensures the design is robust, safe, and ready for implementation. In continuation to the design documents. Now let us understand what are the supporting details required to create design-related documents and why we need them and what phase we have to submit. What are all the design-related documents? 1. Design criteria. 2. Sag and tension calculations. 3. Tower loading calculation. 4. Tower design calculation. 5. Tower structural drawing. 6. Tower accessories drawing. 7. Conductor design. 8. Insulator design. 9. Conductor fittings design. 10. Earth wire fittings. 11. OPGBU fittings. 12. Foundation design. 13. Earthing design. In continuation to the design documents, let us understand why we need them. 1. Design criteria defines the overall technical approach, guidelines, and standards to be followed in the design process. Acts as the foundation for all subsequent calculations and designs, ensuring consistency across the project. 2. Sag and tension calculations ensures proper alignment and tensioning of conductors to avoid excessive sag or snapping under load. Maintains the mechanical stability of conductors while considering environmental factors such as temperature, wind, and ice loading. 3. Tower loading calculation determines the structural loads towers must bear, including wind, conductor weight, and environmental factors. Ensures towers can withstand maximum loads under all operational and environmental conditions. 4. Tower design calculation specifies the geometry, dimensions, and structural strength of towers to handle calculated loads. Ensures the tower structure is safe, stable, and cost-effective. 5. Tower structural drawing provides detailed engineering drawings of tower structures, including dimensions, connections, and assembly details. Acts as a reference for fabricators and construction teams during manufacturing and erection. 6. Tower accessories drawing details the design of accessories such as bolts, nuts, clamps, and brackets used in tower assembly. Ensures compatibility and ease of installation for all tower components. 7. Conductor design specifies the material size and capacity of conductors to ensure efficient power transmission. Ensures the conductor can handle electrical loads without overheating or failing under tension. In continuation to the design documents. 8. Insulator design details the specifications for insulators to prevent electrical leakage and ensure proper conductor support. Ensures insulation performance under high voltage conditions and environmental stresses. 9. Conductor fittings design defines the design of fittings such as clamps, spacers, and dampers used for securing and protecting conductors. Ensures mechanical stability and reduces vibrations in conductors. 10. Earth wire fittings details the design of fittings used for attaching earth wires to towers. Ensures proper grounding of the transmission line to prevent electrical hazards. 11. OPGW optical ground wire fittings specifies fittings for OPGW, which combines ground wires with fiber optic communication lines, provides both grounding and communication capabilities while maintaining mechanical stability. 12. Foundation design details the specifications for tower foundations, considering soil conditions, loads, and environmental factors. Ensures the tower remains stable and secure over its lifespan, even in challenging terrains. 13. Earthing design specifies the grounding system to safely dissipate electrical faults and lightning strikes, protects the transmission line, equipment, and personnel from electrical hazards. In continuation to the design documents. Submission phases for design-related documents. The listed design-related documents must be submitted at specific phases of the transmission line project to ensure timely reviews and approvals. 1. Design criteria. Project initiation phase, pre-construction, acts as the starting point for all design work. It needs to be submitted early in the project to establish the technical guidelines and standards for subsequent designs. 2. Sag and tension calculations, pre-construction phase, submitted along with the initial design package. These calculations are critical for determining the alignment of conductors and ensuring mechanical stability during construction planning. 3. Tower loading calculation, pre-construction phase, submitted with preliminary tower designs to verify that towers can handle expected loads under operational and environmental conditions. 4. Tower design calculation, pre-construction phase, submitted alongside tower loading calculations and drawings for consultant and client approval before tower fabrication begins. 5. Tower structural drawing, pre-construction phase, submitted for approval before fabrication. It provides detailed instructions for manufacturing and assembly, ensuring structural accuracy. 6. Tower accessories drawing, pre-construction phase, submitted before the procurement and production of accessories, ensuring compatibility with the tower structure and alignment with project requirements. 7. Conductor design, Pre-construction phase, submitted early to confirm the specifications of conductors required for efficient power transmission and procurement planning. In continuation to the design documents. 8. Insulator design, pre-construction phase, submitted alongside conductor designs to verify the selection of insulators and ensure proper alignment with safety standards and electrical load requirements. 9. Conductor fittings design, pre-construction phase, submitted prior to procurement and mass production to ensure compatibility with conductors and towers. 10. Earthwire fittings, pre-construction phase, submitted for review and approval to verify the specifications and compatibility of fittings with grounding requirements. 11. OPGW, optical ground wire fittings, pre-construction phase, submitted early in the design process to integrate grounding and communication system requirements into the transmission line. 12. Foundation design, pre-construction phase, with site preparation input, submitted after geotechnical reports are completed. It ensures foundation stability and alignment with soil and terrain conditions before construction begins. 13. Earthing design, pre-construction phase, submitted alongside foundation and tower designs to ensure proper grounding systems are incorporated into the construction plan. In conclusion to our topic, one of design-related documents, all the listed documents are typically submitted during the pre-construction phase, as they form the basis for approvals, procurement, and construction activities. These documents need to be reviewed and approved by the consultant engineers and the client before any physical work or fabrication begins to ensure compliance with technical, safety, and regulatory requirements. Second in our list to understand on document submission is supply-related documents. Supply-related documents are essential to ensure that the materials and equipment used in the project meet the required quality standards, specifications, and compliance requirements. These documents must be submitted for review and approval before procurement, testing, or production. Once the design phase documents are submitted and approved, the details are shared with the approved manufacturers to assist in their understanding and guide the manufacturing process. Before proceeding with mass production, the supplier produces a sample of the product and conducts testing to ensure it complies with the approved design load requirements. These tests are carried out under the supervision of the consultant engineer, CE, and client engineers to verify that the product meets the design specifications and standards. In some cases, these tests are conducted in the presence of third-party inspectors, depending on the requirements and decisions made by the client and CE. Once the tests are completed, the test results and related documents are submitted to the CE for review and approval. Only after the successful completion of the tests and approval of the documents by both the CE and the client can the manufacturer proceed with mass production. 1. Vendor approval. 2. Certificate of compliance. 3. Type test report. 4. Material specifications. 5. Material test certificates. 6. Quality assurance quality control QA/QC documents. 7. Mass production approval request. 8. Factory acceptance test. 9. Packing lists and bills of materials. 10. Delivery schedule. 11. Warranty and guarantee certificates. 12. Logistics and handling instructions. 13. Delivery inspection at store. In continuation to the supply documents, let us understand why we need them. 1. Approved vendor list. Specifies the manufacturers or suppliers approved for providing materials for the project. Details of approved vendors. Certifications and prior approval letters from the client or consultant engineer. 2. Certificates of compliance, COC. Certifies that the supplied materials comply with relevant standards and the client's specifications. Manufacturer's certificate, ensuring compliance with technical and safety standards. Reference to applicable international or regional standards, e.g. ISO, BIS, ANSI. 3. Type test reports. Verifies that the supplied materials meet the performance standards under simulated maximum load and environmental conditions. Results from load tests, mechanical strength tests, and electrical tests. Reports generated by certified testing agencies or labs. 4. Material specifications details the quality, type, size, and grade of materials to be supplied for the project, e.g. conductors, insulators, tower steel, earth wires. Material type and dimensions, technical and mechanical properties, e.g. tensile strength, conductivity, standards and certifications, e.g. ISO, IEC. 5. Material test certificates, provides proof of testing for specific materials, e.g. steel, conductors, insulators, to ensure they meet required specifications. Results of chemical, mechanical, and electrical tests. Certifications from accredited labs or agencies. 6. Quality assurance, quality control documents. Demonstrates the quality control measures taken during material manufacturing. Inspection and testing plans. Non-conformance reports, NCR, and resolutions. 7. Mass production approval request. After successful type testing, this document seeks permission for large-scale production. Proof of successful type testing. Details of production schedules and timelines. 8. Factory acceptance test reports. Confirms the quality and compliance of materials and equipment before dispatch from the factory. Inspection reports by quality assurance teams. Certificates from third-party inspectors. 9. Packing lists and bills of materials, BOM. Provides a detailed inventory of materials being dispatched to the project site. Quantity and description of materials, serial numbers and identification markings. 10. Delivery schedules. Outlines the timelines and milestones for the delivery of materials to the site. Itemized delivery timelines. Transportation and logistics plans. 11. Warranty and guarantee certificates. Ensures the supplied materials and equipment are covered for defects or failures during a specified period. Duration and scope of the warranty or guarantee. Conditions under which the warranty applies. 12. Logistics and handling instructions. Provides guidelines for safely transporting, handling, and storing materials. Specific handling requirements for delicate items, e.g., insulators, conductors. Storage conditions to prevent material degradation. 13. Site inspection, to check whether the materials delivered match the specifications outlined in the approved design and procurement documents. To confirm that the materials are free from defects, properly manufactured, and capable of performing as intended. To ensure that the delivered materials meet the standards and certifications agreed upon in the contract. During the inspection, they check each material against the approved documents, such as type test reports, packing lists, and certificates of compliance. Third topic on documents is construction phase. In construction phase, let us split in 3 parts: before, during, and post. The construction phase of a transmission line project requires the submission and approval of various documents by the consultant engineer, CE, at 3 key stages. 1. Before construction phase. 2. Execution phase. 3. Completion phase. These approvals ensure that the work complies with design specifications, safety regulations, and contractual requirements. First, let us understand what are the documents required. Before construction phase starts for any individual activity. Before construction begins, the CE must review and approve detailed plans and documentation to ensure the groundwork for execution is properly laid out. 1. Method statements. 2. Route survey. Plan and profile. 4. Check survey. 5. Resources allocation. 6. Nomenclature. 7. Design mix. 8. Rebar test report. 9. Water test report. 10. Leg extensions. 11. Benching and retaining wall. 12. Soil investigation. 13. Subcontractors. 14. Store plan. 15. Work schedule. 16. Billing forecast. 17. Wearing spears and lights installation. 18. HSE. 19. QA and QC. Now let us understand in brief. 1. Method statements. Details the step-by-step procedures for executing specific construction activities. For example, all type of survey, access road making, tree cutting, all phase of and type of foundation installation, all phase of and type of tower erection, and all phase of stringing, conductor, earth wire, and OPGW, which ensures compliance with safety, environmental, and technical standards. 2. Route survey. Documents the surveyed alignment of the transmission line route, the exact path of the line with GPS coordinates, terrain features, and obstructions. Identification of critical points such as road crossings, river crossings, and restricted areas. Ensures the route avoids sensitive areas, complies with regulatory requirements, and minimizes construction challenges. 3. Plan and profile. Provides a detailed graphical representation of the transmission line route, including vertical and horizontal profiles, tower locations, elevations, and distances between towers, ground clearances, conductor sag, and tension specifications. Acts as a base document for foundation design, tower erection, and stringing. 4. Check survey. Conducted after the route survey to verify the alignment and tower locations before construction. Revalidation of coordinates and measurements for accuracy. Adjustments for any deviations identified during the initial survey. Ensures accuracy and prevents misalignment during construction. 5. Resources allocation. Details the allocation of manpower, equipment, and materials required for the project. Number of workers, types of machinery, and material stockpiles at various stages of construction. Helps in planning and monitoring resource usage to avoid delays or shortages. 6. Nomenclature. Provides a systematic naming and numbering convention for project documents, towers, and components. Codes for documents, towers, conductor spans, and inventory items. Ensures consistency and easy reference across all project documentation. 7. Design mix. Specifies the concrete mix design for tower foundations, considering soil conditions and load requirements, proportions of cement, aggregates, water, and admixtures. Test results for compressive strength and workability. Ensures the foundation is strong enough to support the tower under all loading conditions. 8. Rebar test report. To verify that the reinforcement steel bars, rebar, used in the construction meet the required mechanical and chemical properties as per the project specifications and applicable standards, e.g. ASTM, BS, or IS codes. Diameter of the rebar, e.g. 12 mm, 16 mm. Weight per meter to ensure the correct size is supplied. The maximum stress the rebar can withstand before failure. The stress at which the rebar begins to deform plastically. The rebar's ability to stretch without breaking. Percentages of carbon, manganese, silicon, sulfur, and phosphorus to ensure corrosion resistance and durability. Details on how the test was conducted, e.g. tension tests, bend tests, rebend tests. 9. Water test report. To confirm that the water used for concrete mixing and curing meets quality standards. Impurities in water can adversely affect the strength and durability of concrete. Ensures compliance with standards such as IS 456 or ASTM C1602. Location and type of water source, e.g. river, borewell, or municipal supply. The water should be clear and free from visible impurities. pH level should generally be between 6 and 8. Chlorides. Excess chlorides can cause corrosion in steel reinforcement. Sulfates. Excess sulfates can lead to expansion and cracking in concrete. Dissolved solids must be within permissible limits to avoid compromising concrete strength. Presence of oil, grease, or algae, which can adversely affect bonding between cement and aggregates. Measures calcium and magnesium content, which should be within acceptable limits. (10) Leg extensions. Design modifications for extending tower legs in uneven terrain to maintain tower height and alignment. Detailed drawings and calculations for leg extensions. Specifications for materials and connections. Maintain structural stability and alignment in challenging terrains. 11. Benching and retaining wall. Documents related to slope stabilization and leveling of tower sites in hilly or uneven terrain. Design and dimensions of retaining walls and benching works. Soil stabilization measures and material specifications. Ensures the safety and stability of tower foundations in sloped areas. 12. Soil investigation. Determines the soil properties at tower locations to ensure appropriate foundation design. Soil type, bearing capacity, and water table levels. Recommendations for foundation type and depth. Prevents foundation failures by matching the design to site-specific conditions. 13. Subcontractors. Documents related to subcontractors engaged in specific activities like foundation construction, tower erection, or stringing. Subcontractor credentials, scope of work, and agreements. Compliance with safety, quality, and contractual standards. Ensures accountability and alignment with project requirements. 14. Store plan. Layout and management plan for the storage of materials and equipment at the construction site. Locations for storing conductors, towers, insulators, and other materials. Security measures and inventory management systems. Prevents material loss, damage, and delays in retrieval. 15. Work schedule. Timeline for project activities from foundation works to stringing and commissioning. Start and end dates for each activity, along with dependencies. Milestones for progress tracking. Facilitates efficient planning and monitoring to avoid delays. 16. Billing forecast. Projected costs and cash flow requirements for each phase of construction. Cost breakdown for materials, labor, equipment, and subcontractors. Payment schedules and anticipated billing milestones. Ensures financial planning and timely payments to avoid project interruptions. 17. Warning spears and lights installation. Ensures visibility of towers and lines to prevent accidents, particularly near airports or urban areas. Specifications and locations for installing aviation lights and warning markers. Compliance with aviation safety regulations. Enhances safety by ensuring visibility to aircraft and nearby personnel. 18. HSE, Health, Safety, and Environment. Plans and policies to ensure worker safety, environmental protection, and compliance with local laws. Risk assessments, emergency response plans, and training schedules. Waste management and pollution control measures. Prevents accidents, ensures regulatory compliance, and promotes sustainable practices. 19. QA and QC, Quality Assurance and Quality Control. Framework for ensuring materials and construction processes meet quality standards. Inspection and test plans, checklists, and quality benchmarks. Documentation of tests conducted and approvals received. Maintains high-quality standards, ensuring the durability and reliability of the transmission line. Each of these document submissions plays a vital role in ensuring the project is planned, executed, and monitored efficiently, safely, and in compliance with contractual and regulatory requirements. These documents facilitate smooth coordination among stakeholders and contribute to the overall success of the project. Now let us understand the documents required during execution phase. During the construction phase of a transmission line project, specific documents must be prepared, submitted, and approved to ensure the quality, safety, and compliance of the work. These documents primarily serve as inspection reports, test results, and certifications that verify the completion of various activities and support the successful execution of the project. 1. Check Survey Site Inspection Report. 2. Soil Investigation Report. 3. Location. Soil Classification Report. 4. Concreting Sample Test Reports. 5. Backfilling Compaction Test Report. 6. Foundation Uplift Test Report. 7. Soil Earth Resistance Report. 8. Tower Tightening Verticality Test Report. 9. Soil Earth Resistance Report. 10. Conductor Compression Joints Recording. 11. Sagging Recording. 12. OPGW Continuity Test Report before and after installation. 13. End-to-end Test Report. 14. Ground Clearance Report. 15. Joint Measurement Certificate for every activity. 16. Final Inspection Report. 17. Electrical Line Continuity Test Report. 18. Line Energization Report. Now let us understand these topics in brief. 1. Check Survey Site Inspection Report. Verifies that the site aligns with the approved route alignment and tower locations. Confirmation of tower positions, offsets, and site conditions. Any deviations from the initial route survey and corrective actions. Ensures the site is ready for foundation and tower erection. 2. Soil Investigation Report. Provides detailed analysis of soil properties for foundation design. Soil bearing capacity, moisture content, and compaction properties. Recommendations for foundation types and depths. Prevents foundation failures by ensuring compatibility with the soil. 3. Location. Soil Classification Report. Classifies the soil at specific tower locations to determine the type of foundation required. Soil texture, composition, and classification. Example: clay, silt, sandy. Variations in soil conditions across the site. Helps in selecting appropriate foundation designs for varied terrains. 4. Concreting Sample Test Reports. Confirms the quality of concrete used in foundation works. Results of compressive strength tests, slump tests, and water-cement ratio. Compliance with approved design mix specifications. Ensures the durability and load-bearing capacity of the concrete. 5. Backfilling compaction test report verifies the compaction quality of soil used for backfilling around foundations. Compaction density and moisture content achieved during backfilling. Compliance with project specifications. Prevents settlement or erosion around foundations. 6. Foundation uplift test report. Tests the foundation's ability to resist uplift forces caused by conductor tension and environmental factors. Load applied and displacement recorded during the test. Foundation stability against designed uplift forces ensures the structural stability of the foundation. 7. Soil earth resistance report measures the earth resistance at tower locations to ensure proper grounding. Earth resistance values in ohms. Compliance with safety standards for fault current dissipation. Prevents electrical hazards by ensuring effective grounding. 8. Tower tightening verticality test report verifies that the erected towers are perfectly vertical and all bolts are securely tightened. Verticality measurements using instruments like theodolites. Inspection of bolted connections for proper torque and alignment. Ensures the structural stability and alignment of towers. 9. Conductor compression joints recording documents the installation of compression joints used to connect conductors. Specifications of compression tools, dies, and pressure applied. Joint locations and test results for joint integrity. Ensures reliable conductor connections without electrical or mechanical failures. 10. Sagging recording verifies the conductor sag and tension between towers to ensure compliance with design specifications. Sag measurements at various temperatures and spans. Adjustments made to achieve the correct sag. Ensures proper conductor clearance and tension for operational safety. 11. OPGW continuity test report before and after installation tests the continuity of optical ground wire, OPGW, to ensure it functions properly. Pre-installation and post-installation results for optical fiber connectivity. Signal attenuation and reflection measurements. Ensures OPGW reliability for communication and grounding. 12. End-to-end test report confirms the continuity and integrity of the transmission line from start to end. Line resistance, voltage drop, and fault detection results. Compliance with electrical standards. Verifies the readiness of the line for energization. 10. Ground clearance report ensures that the conductors maintain the minimum clearance required from the ground and obstacles. Clearance measurements at different spans and locations. Adjustments made to ensure compliance with safety standards. Prevents accidents by ensuring safe clearance levels. 14. Joint Measurement Certificate, JMC, for every activity. Certifies that specific construction activities, e.g. foundation, erection, stringing, have been completed as per the approved specifications. Measurements and observations for the completed activity. Joint approval by the contractor, CE, and client engineers. Serves as a record of work completion and approval. 15. Final Inspection Report. Summarizes the findings from the final inspection of the completed project. Observations on structural, electrical, and safety aspects. List of any punch points or corrections required. Confirms the project's readiness for commissioning. 16. Electrical Line Continuity Test Report confirms the continuity and integrity of the electrical connections in the transmission line. Test results showing no discontinuities or faults in the electrical circuit. Ensures the line is ready to carry current without interruptions. 17. Line Energization Report certifies the successful energization of the transmission line. Observations during the energization process, e.g. voltage, current, and faults. Approval by CE and client engineers. Marks the official completion and commissioning of the project. These documents ensure quality assurance, compliance, and safety throughout the construction phase. They act as a record of all key inspections, tests, and approvals supporting the successful completion of the project. Fourth, let us understand work completion-related documents. Once the construction phase is complete, several important documents need to be prepared, submitted, and approved. These documents serve as final records to validate the completion of the project and ensure compliance with contractual, regulatory, and safety requirements. They also help in the smooth transition of the project from the contractor to the client. Below, we explain these post-construction documents and their significance. 1. As-built drawings. 2. Joint measurement certificate for all activity. 3. Taking over certificate. 4. Line energization certificate. 5. Line maintenance intimation. 6. Final acceptance certificate. 7. DLP intimation. We have one remaining documentation activity to cover, which is related to the commercial aspects of the project. I plan to address this once all construction activities are completed. In that session, I will comprehensively cover all commercial aspects, including guarantees, budgets, billing, financial control, MIS, and everything involving commercial and financial management from the project's initiation to its successful closure. Once the construction phase is complete, several important documents need to be prepared, submitted, and approved. These documents serve as final records to validate the completion of the project and ensure compliance with contractual, regulatory, and safety requirements. They also help in the smooth transition of the project from the contractor to the client. These documents are critical during the final phase of a transmission line project as they ensure proper handover, completion certification, and clarity regarding post-completion responsibilities like maintenance and defect liability. Below is a detailed explanation. 1. As-built drawings. As-built drawings are the final version of project drawings reflecting any changes or modifications made during the construction phase. Exact tower locations, dimensions, routing, and profiles. Changes to original design, such as adjustments for terrain, soil conditions, or site challenges. Updated specifications for foundations, conductors, and components. Provides an accurate reference for future maintenance, repairs, or modifications. Serves as a legal record of the completed project. 2. Joint Measurement Certificate, JMC, for all activities. A JMC is prepared to validate the completion of each activity, signed jointly by the contractor, consultant engineer, CE, and client engineers. Measurements of work completed, e.g., foundation dimensions, tower erection, conductor sag. Certification of compliance with approved standards and specifications. Acts as proof of work completion and supports billing and payment reconciliation. Ensures accountability and avoids disputes between stakeholders. 3. Taking over certificate, TOC. Issued by the client to confirm that the project has been completed and is ready for handover. Acknowledgement of successful project completion as per the contract terms. Any punch points or minor pending works listed for resolution. Marks the official transfer of the project from the contractor to the client. Signals the start of the guarantee period. 4. Line energization certificate. Certifies that the transmission line has been successfully tested, energized, and is ready for operation. Test results confirming successful energization. Voltage, current, and system stability observations. Safety compliance checks prior to energization. Demonstrates that the line is operational and safe for power transmission. Marks the commissioning of the project. Five. Line maintenance intimation. Provides formal communication to the client regarding the handover of maintenance responsibilities. List of tasks for routine and preventive maintenance. Example, inspections, repairs. Responsibilities of the client or maintenance team post-handover. Ensures the client is aware of their responsibilities to keep the transmission line in optimal condition. Facilitates smooth maintenance operations post-project completion. 6. Final acceptance certificate, FAC, issued are all pending works, punch points, and testing have been completed to the satisfaction of the client. Certification that all contractual obligations have been met. Confirmation of satisfactory operation post-energization. Marks the final and complete acceptance of the project by the client. Allows the contractor to close out the project contractually and financially. 7. DLP intimation, defect liability period. Official intimation regarding the start of the defect liability period, DLP, during which the contractor is responsible for addressing any defects. Duration of the DLP, example, 12 or 24 months as per contract. List of works covered under the DLP, example, structural defects, electrical failures. Communication process for reporting defects. Ensures accountability for any post-construction defects within the defined period. Guarantees the project's performance and durability under real-world conditions. These documents collectively ensure the smooth handover, operational readiness, and final acceptance of the transmission line project. They provide a comprehensive record of completed works, clarify responsibilities, and safeguard the project's long-term quality and functionality. With this, we conclude the topic of project documentation, having covered all essential documents except for those related to the commercial aspects, which will be addressed at the end of the construction phase. In this chapter, we have learned the following topics: design-related, supply-related, construction phase documents, work completion-related documents, and this brings the concluding part about project documentation. In our study program, we have consistently emphasized the principles of professional ethics, covering all related topics in previous chapters. We have also introduced the subject of legal compliance and plan to explore additional areas, including human resources, HR and health, safety and environment, HSE, in future chapters. Today, as a continuation, we will delve into legal compliance in corporate business for professionals and staff. This new topic aims to provide valuable insights, and we hope it will be beneficial for all our viewers. Legal compliance refers to the adherence to laws, regulations, standards, and ethical practices that govern corporate activities. For corporate professionals, understanding and following these requirements is essential for maintaining the integrity, reputation, and success of both the individual and the organization. Legal compliance is a critical component in corporate governance and business operations, helping professionals navigate complex regulatory environments, avoid legal issues, and ensure ethical business practices. Let us understand the aspects of legal compliance for corporate professionals. These are following topics we will be covering in our chapters. 1. Relevant laws and regulations. 2. Corporate governance and ethical standards. 3. Compliance with employment laws. 4. Data privacy and protection. These 4 topics we have gone through in our earlier chapters. 5. Anti-corruption and anti-bribery laws. This topic we will go through in this chapter. The following topics will be covered in our upcoming chapters: environmental compliance, financial and tax compliance, intellectual property compliance, implementing legal compliance in the workplace. Five, anti-corruption and anti-bribery laws. Anti-corruption and anti-bribery laws are essential frameworks that ensure ethical business conduct, promote transparency, and prevent unlawful activities such as bribery, fraud, and corruption. These laws are particularly crucial for professionals involved in corporate transactions, both domestically and internationally, as non-compliance can lead to severe legal, financial, and reputational consequences. Anti-corruption laws, such as the Foreign Corrupt Practices Act, FCPA, and the UK Bribery Act, are 2 of the most well-known regulations globally. First, enacted in the United States, the FCPA applies to U.S.-based companies, their employees, and any foreign entities conducting business in the U.S. It prohibits the offering, payment, or promise of anything of value to foreign officials to influence decisions, secure business, or gain an improper advantage. The FCPA has 2 key provisions. Anti-bribery provisions prohibit corrupt payments to foreign officials. Accounting provisions require companies to maintain accurate financial records and implement robust internal controls to prevent hidden or improper payments. These provisions ensure fair competition and promote ethical conduct in international operations. Companies operating globally must comply with these laws and ensure they do not engage in bribery under any circumstances. Second, the UK Bribery Act 2010 is broader in scope than the FCPA and applies to all individuals and companies operating in the United Kingdom, including global businesses. Unlike the FCPA, the UK Bribery Act covers both domestic and international bribery and applies to private individuals as well as public officials. Active bribery, offering or giving a bribe. Passive bribery, receiving or accepting a bribe. Bribery of foreign officials, specifically targets bribery in international dealings. Failure to prevent bribery. Companies can be held liable if they fail to implement adequate procedures to prevent bribery. The UK Bribery Act provides a zero-tolerance approach to corruption and bribery. Companies must demonstrate that they have effective anti-bribery systems in place to avoid liability. 1. Policy enforcement. To remain compliant with anti-corruption laws, organizations must establish clear policies and ensure their enforcement through ongoing education, monitoring, and internal controls. A. Avoid actions that could be interpreted as bribery or corruption. Professionals must refrain from activities that may be perceived as bribery, such as offering money, gifts, favors, or promises in exchange for business advantages. Making facilitation payments, small payments to expedite routine tasks. B. Gifts and entertainment policies. Organizations should establish clear guidelines on offering or receiving gifts, entertainment, or hospitality. These activities must be transparent, modest, and aligned with company policies. C. Interactions with public officials. Special care is required when interacting with public officials or government entities, as these interactions are highly scrutinized. Proper approvals and documentation should be maintained for such engagements to ensure compliance. D. Internal controls and training. Companies must implement systems to monitor transactions and detect suspicious activity. Ensure accurate financial reporting and compliance with policies. Regular training programs should be conducted to educate employees on anti-bribery policies, legal frameworks, and ethical standards. 2. Why compliance is essential. A. Legal compliance avoids penalties, fines, or legal prosecution for individuals and organizations. B. Reputation management ensures trust and credibility in the marketplace. Corruption scandals can severely damage a company's reputation. C. Business integrity promotes ethical practices, fair competition, and transparency in global business operations. D. Avoidance of financial loss. Companies can face hefty fines, asset forfeiture, and operational disruptions due to non-compliance. Anti-corruption and anti-bribery laws, such as the FCPA and the UK Bribery Act, set the global standard for ethical business conduct. To remain compliant, professionals must strictly adhere to organizational policies on gifts, entertainment, and public official interactions. Companies must prioritize policy enforcement, employee training, and internal controls. By maintaining integrity and transparency, businesses can avoid legal consequences and contribute to ethical, sustainable operations in today's interconnected global economy. Today's quote is from Marilyn Vos Savant. To acquire knowledge, one must study, but to acquire wisdom, one must observe. This quote highlights the difference between knowledge and wisdom, emphasizing the processes required to achieve each. Knowledge is gained through study, which involves reading, learning, and understanding concepts, theories, or facts. It is an accumulation of information that comes from formal education, books, or research. Wisdom, on the other hand, goes beyond just acquiring information. It requires observation, the ability to carefully watch, reflect, and learn from experiences, people, and situations. Wisdom is about applying knowledge in practical, thoughtful, and ethical ways to navigate life effectively. The quote implies that while studying is essential for gaining knowledge, wisdom comes from life experience, critical thinking, and the ability to observe and understand the deeper meaning of things. It encourages a balance between academic learning and experiential understanding to lead a more insightful and fulfilling life. As we wrap up our session, I encourage you to subscribe and hit the bell icon so you won't miss any of our upcoming chapters. It's your gateway to mastering transmission line supervision. That brings us to the end of today's Chapter 10 about project documentation. Next time, we'll dive into construction activity. Until then, take care and thank you for watching.